This is lesson 3.1 of our Intro to Algebra book. This is on page 75 in Mrs. Walker's class. And lesson 3.1 is titled Equations and Solutions. Okay, and here's your warm-up for this lesson. Blended that in weird. There we go. Okay, warm-up. Evaluate each expression. And remember that when we evaluate an expression, it simply means plug it in and do the math. We say that a lot, huh? Plug it in and do the math. All right? So the first expression is y minus 14. 14 subtracted from y. When y equals 29. So plug it in and do the math. All right. Number 2 is 7 plus 2x when x equals 0. Number 3 is a minus 3 all squared when a equals 10. All right? So that's your warm-up. Get that worked out. And when you are done, continue on with our I can statement. What we will be learning during this lesson. I can determine if a number is a solution of an equation. All right, I can determine if a number is a solution of an equation. All right, that's what we're going to learn how to do today. And basically what this is we're going to be talking about equations instead of expressions. But you're going to be evaluating the equation instead of an expression. So let's talk real quick about the differences here of what is an expression and what is an equation. All right. So let's say that I have 3 plus x. All right. So 3 plus x is an expression. We've been talking about that a lot. 3 plus x is an expression. Now, actually, it's not only an expression, but I know that it's a special type of expression. It is an algebraic expression because it has a variable. If I had 3 plus 2, that would be just a plain old expression. All right? But because I have this variable in this one, it is an algebraic expression. Now, if I had 3 plus x equals 5, now this is an expression. Let me erase that. Hold on. This is an equation. Okay? Equation. So equal, equation. What makes this an equation and not an expression is the fact that it has an equal sign here. So 3 plus x equals 5 is an equation, where this is simply an expression. Also, when it's an equation, on each side of the equation, there is an expression. We have an algebraic expression on this side of the equation and just a regular expression on this side. Yes, a single term or a single constant can be an expression all on its own. Okay, so that's the difference between an expression, an algebraic expression, and an equation. All right? Okay, so now that we've got that back in our memory, that vocabulary, let's get on with our lesson. So I've got a little vocab sheet that I'm going to put in the usual upper left corner here, and get my glue going. Tiny little tadpoles. Teeny tiny. Elmer's glue is like magic. The teeny tiniest bit will bond two pieces of paper together so well. So much better than stick glue if you know how to use it right. All right, here we go. So we've got our little vocabulary sheet. We have some new pieces of vocabulary to talk about. First, I'm going to highlight. Okay, vocabulary. And then equation. So our actual definition for what is an equation is, it says here, a mathematical sentence that contains an equal sign between two expressions. And that's exactly what we were talking about right here, right? It's a mathematical sentence. This whole thing is a mathematical sentence that contains an equal sign between two expressions, one here and one here. That's the definition of an equation, all right? So the other piece of vocabulary we have here is solution. A solution is the value that makes an equation true, all right? So here's what they're talking about. Right here, x plus 7 equals 20. That is an equation. X plus 7 equals 20 is an equation. We have an expression, an algebraic expression of x plus 7 on one side of the equal sign and a constant, 20, on the other side. All right? Now, the value of x that makes this equation true is 13. 13 is the solution of the equation. Now, we can prove that by plugging it in where the variable was. So now we have 13 plus 7. 13 plus 7 is 20. We keep the equal signs lined up, and we see that we have 20 and 20 on both sides of the equations. The expressions on both sides of the equal sign now match, and so it is true that 13 is a solution for x plus 7 equals 20. So the equation is true for the solution of 13. Okay? So we're gonna see how this works in a variety of different problems, and hopefully now you can see what I was talking about, how this is very similar to what you've done before with evaluating expressions. We're just going to be plugging it in and doing the math, all right? Okay, so with my blue pencil, I'm going to write up here. Oops, well, I'm not going to write now. Broken lead. Looks like I sharpened that one a little too far. All right, let's see if we can get this working. All right. Live video, folks. I think this is the same pencil I had trouble with before too. Breaks easily. Alright, hold on a second. I think maybe we have a point we can work with now. I tell you, when I'm using colored pencils, I always use Crayola. If you use those cheap Rose Art ones, I mean, these are Crayolas, and every once in a while I still get one that's tricky to sharpen, but it'll be a nightmare if you use the cheap ones. All right, here we go. Let's see if we can keep a point now. Determine if the number given is the solution. That's the instructions for our examples we're going to do now. Determine if the number given is the solution. So, problem number one. Problem number one is x minus 5 equals, remember these are equations, x minus 5 equals 12. All right, and it asks, is 7 the solution? I'm going to have to write small there, huh? All right, is it? Well, we have to prove whether it is or not by plugging in 7 for the variable. So, 7 minus 5. Is it equal to 12? Okay, that's how we write it, with that tiny little question mark above the equal sign, because we don't know yet. We haven't proven it. All right, so we keep the equal signs lined up. 7 minus 5 is 2. Bring down the expression on the other side of the equal sign. Is 2 equal to 12? Okay, no, 2 is not equal to 12. So we change this equal sign with a slash through it to mean 2 is not equal to 12. And so then over here we would write not a solution. Not a solution. So our answer for is 7 a solution? It is not a solution. Okay? That's all it is. We just take what they are asking us, is it a solution, plug it in for the variable, and prove whether it is or whether it isn't. All right? So let's look at another example. Our next one is 8y. 8y equals 32. All right? And it asked us is 4 the solution. I should capitalize that. Is 4 the solution. All right, is 4 the solution. So first we have to set it up. 8y means 8 times y. We're going to plug in 4 for the y. So we say 8 and in parentheses 4. Keep the equal signs lined up. Bring down the expression on the other side of the equal sign, which is 32. And then we do the math. 8 times 4 is 32. Keep the equal signs lined up and bring down the expression on the other side of the equal sign. 32 equals 32. Yes, 32 does equal 32. So 4 is a solution. It is true. You can write is a solution or yes, it is a solution. All right, answer in the affirmative. All right. So one more example. Number 3. We have m over 3 equals, oh, you know, I forgot my little teeny tiny question mark there, huh? Okay, equals, what was it? Oh, 9. Equals 9. All right. So they're asking, is 27 the solution? Is 27 the solution? All right. Well, let's plug it in and find out. Okay. So for m we have 9. So 9 over 3. Is it equal to 9? Well, 9 divided by 3. 3 goes into 9. Oh, not 9. I got a lot of mistakes today. Okay. Bear with me. 27 is what we're supposed to be plugging in. There we go. All right. 27 divided by 3 is 9 equals 9. 9 does equal 9, of course. And so it is a solution. And there's my answer. All right. So there's 3 different kinds of problems that we have 3 different kinds of equations that we have evaluated for a solution to determine whether it is a solution or not. Now, on your worksheet, there's one other way that they ask you to determine a solution or not, and that's with a table. Very, very similar to the table that you've worked with before when you were evaluating expressions. So let's see, I need 1, 2, 3, 4, 5, 6, 7 lines. What if I got 1, 2, 3, 4, 5, 6, 7? Yeah, I'm just going to barely make this fit here, huh? All right. So I think I'm going to take my light green pencil here and just kind of divide the work. There we go. And now I've got that and across. And here's my heading space, and then I have 3 areas of work. So over here is my X, that's my input value. And here is where we're going to answer the question, is it a solution? Is it a solution? And here is my equation I will be evaluating. 14 minus X equals 8. And the values I'm going to check for are 4, 6, and 9. All right, that's how we set that up. Okay, so 14 minus, I'm going to put 4 in for the variable, 4 equals 8. Well, does it equal 8? We have to prove. 14 minus 4 is 10. Bring down the equal sign and the expression on the other side. Does 10 equal 8? No, it does not. 10 does not equal 8. And so we will answer, is it a solution? No. Okay, that's how it works. We'll do the same one for the other 2 values. 14 minus 6, we plug in 6 for the variable of X, equals 8. Well, does it equal 8? There's my little question mark. 14 minus 6 is 8. Bring down the equal sign and the equation, the expression on the other side of the equation. 8 equals 8. Yes, it does. So the answer to, is it a solution? Yes, it is a solution. All right, last one. 14 minus input 9 for our variable. 9 equals 8. 14 minus 9, that's right, we want, does it equal 8? 14 minus 9 is 5. Keep the equal signs lined up and bring down the 8. Does 5 equal 8? Well, of course not. So I'm going to turn that into a does not equal sign, and in my solution column say no. 9 is not a solution for the equation 14 minus x equals 8. All right? Okay, so that's the notes for this lesson. Let's go on with some practice problems. Okay, here are the practice problems for lesson 3.1. The first one, there are 3 problems very similar to the ones, well, actually 4 problems if you're including the table one, and they're all very similar to what we just did in the notes. So, number 1 asks, is 8 the solution of the equation x minus 2 equals 6? Number 2 asks, is 4.5 the solution to the equation y over 1.5 equals 4? Number 3, is 9 the solution to the equation 6y equals 54? And then number 4 is the table where we have 3 different inputs that you will check for the solution of 9 plus x equals 14. All right, so I'm going to try and get these all in frame where you can pause and work. Let's see, it looks like I'll only be able to get the first 2 and the last 2. So here's the first 2. And 3 and 4. Okay, let's see how these work. Number 1. First thing I'm going to do is plug in 8 for my variable. So 8 minus 2, is it a solution, or is it equal to 6? All right. 8 minus 2 is 6. equals 6. 6 equals 6, so it is a solution. And I'm just going to write yes. It is a solution. That's the answer. All right. And the next one is, okay, we're going to plug in 4.5 for y. So we've got 4.5 over 1.5 equal to 4. Is it equal to 4? Well, 1.5 goes into 4.5 3 times. Keep your equal signs lined up. Bring down the 4. Am I in frame? Oh, there we go, sorry. And 3 is not equal to 4, and so no, this is not a solution. All right. The next one, number 3, we have, is 9 the solution to the equation 6y equals 54? All right. Well, I have to plug in 9 for y, so I'm going to multiply 6 times 9. Is it equal to 54? Well, 6 times 9 is 54. Bring down the equal sign and the other side of the equation, 54. 54 is equal to 54. And so, yes, 9 is a solution. All right? Okay, now let's do our table down here. Here we go. We have this equation, 9 plus x equals 14, and we're first going to try out 3 and see if it's a solution. So, 9 plus 3, is it equal to 14? Well, 9 plus 3 is 12, and that is not equal to 14. So the answer is no. All right? So we'll try it on the next one. We have 9 plus 4. Is it equal to 14? 9 plus 4 is 13. That is not equal to 14. So 4 is not a solution to 9 plus x equals 14. So we'll plug in 5. 9 plus 5. Is it equal to 14? 9 plus 5 is 14. Bring down the equal sign on the other side of the equation. 14 equals 14. So 5 is a solution to 9 plus x equals 14. All right? So that's how you do those problems. Let's take a look at your worksheet. Your worksheet, the top part of it looks very much like the 3 examples that we did in the notes. You need to show your work exactly like we did in the notes. The next 4 problems here are the tables, again, just like what we did in our notes and on the practice problems as well. In the bottom, it's the same as the top. You're just determining a solution. Let's see, I should have circled that too. Make sure you're using x as your variable, and the only difference is you have to write the equation from the words. And then over here, it's asking you, is 13 the solution to the equation that you wrote? And then you'll prove whether it is or is not, the same way that you do with these problems right up here. Okay, so notice that I had you circle that is it the solution to the equation, because often students will write out the equation from the words here and stop at that. Notice this is the number they want you to try out for the variable to determine, is this the solution for the equation you write here. Okay. All right, so that's your worksheet for lesson 3.1, and here's your exit ticket. Exit ticket I don't show you the answers to. I don't show you how to work them out. They're excuse me, they are for extra practice, or your teacher may use it in some other assessment way. Okay, so that is lesson 3.1 out of the Intro to Algebra book. Remember, the only way to learn math is to do math, and mistakes are proof that you're learning.